Okay, hello. So today we're going to talk about multiplying rational expressions and dividing rational expressions. So this is part one of our video notes. The second video is going to talk about dividing rational expressions. Okay, so right here you can go ahead and title your notes, Unit 3.12a, multiplying rational expressions. Okay. The vocabulary that we're going to talk about in this video are conjecture, product, factor, simplified denominator, factors, and numerator. Okay, and here we go. So this special rule right here, I want you all to write this in your notes as a key point. Okay, and all this basically means if we can multiply, or when we multiply two fractions together, we will get a product for the numerator and the denominator, and then we would need to simplify. Now, the same rule will apply for our rational expressions. So, for example, we have 2/3 times 4/5. So, I'm going to go ahead and write this as 2 times 4, and then we have 3 times 5, and then you would get 8 over 15, right? So you just multiply straight across. Now, the same thing would occur for a rational expression, which will be, this one we will cover in example 1. Okay, so one key term that may be slightly new is conjecture. So conjecture is a statement believed to be true based on observations. So based on what we've done with our rational numbers as fractions, we want to see if we can apply the same rules with rational expressions, okay, which is what we're going to do here. So it says, make a conjecture about the product x to the third over 4 times 16 over x. What will it be? Explain your conjecture and give evidence that it is correct. So we need to explain and then provide evidence. So right here, the way we're going to do this is by multiplying x to the third over 4 times 16 over x. Now I'm going to multiply this, so I get x to the third times 16, and then 4 times x, right? And then we know that will eventually give us x to the third, or 16x to the third, or x to the third, and then 4x. Now, when we are multiplying rational expressions, we also want to simplify our problem, okay? And the one way we can do this is by separating 16x to the third into its factors. So 16x to the third can be 4x times 4x squared, okay? And the reason why I'm going to do that is because I eventually want to apply the property of 1 with the denominator. So over here, this is like 4x times 1, okay? So then from here, I can clearly see I can apply the property of 1, 4x over 4x, and I get 1. Therefore, my answer will be 4x squared over 1, or just 4x squared, right? So then it tells you here to make a conjecture. So what I'm going to say here is I believe that the product for the original rational expression will be 4x squared because it follows the same rules as rational numbers by multiplying the numerator and denominator, and then simplifying. Okay, so that's my conjecture. All right, moving on to the second part. Okay, so here we still have, it says make a conjecture. So based on our observations, what we know about rational numbers and how to multiply them with fractions. We want to find the product, right? So we want to find the answer to this rational expression. What will it be? Explain your conjecture and give evidence, okay? So remember, product means to multiply. So we know we just need to multiply, which will eventually lead to simplify. Okay, All right, so I'm gonna do the same process, but with just different expressions. So I have 4, or x to the third over 4y times y squared over x, and then I would get x to the third y squared for y x, okay? Now my goal is to apply the property of 1 eventually, so I'm going to expand this. I'm going to do x times x times x times y times y, and then I'm going to have 4 times x times y, okay? So then I'm doing this so I can, if you notice, I use commutative property mainly to strategically align these up to apply the property of 1. So x over x gives me 1, and then y over y also give me 1, and then I get x squared y over 4, and that is my answer, okay? So I'm going to apply, or I'm going to write my conjecture. So, so here I can say I believe that the, oh, how can I make this bigger? Okay, so I believe the product for the original rational expression will be x squared y divided by 4 because it follows the same rules as rational numbers, or I should have said as same rules as multiplying rational numbers by multiplying the numerator and denominator and then simplifying. And that's my conjecture. Moving on. Okay, so for example 2, this one may appear a little bit tricky, but it is not. Some of you all may naturally want to distribute this 1/3, but when we're multiplying, we can use commutative property to switch some of these around, okay? So what I'm actually going to do is I'm going to rewrite this as 1/3 times x minus 2 by 9, right? So what I can do here is apply commutative property, switch my factors. So I get 9 over 1 times x minus 2. Eventually I'll get 3 here times x minus 2. And then distributing this 3. And I will get now 3x minus 6, and that's my answer. So the whole point of this example is for you all to realize you don't have to distribute that 1/3. What you can do is apply commutative property to move our factors around so we can be more strategic, right? All right, so here are your key steps when you are multiplying, or I should say key steps, right? So when you are multiplying rational expressions that are a little bit larger, okay? So your first step is to always factor out GCF, okay? Or you may have some special factors like difference of squares, difference of cubes, sum of cubes, whatever it may be. Or maybe you need to factor out trinomial. So factor out GCF is your go-to, but you may have to do trinomials, right? And getting those into 2 binomials. Or you may have difference of squares, right? Difference of squares, and so on, okay? Or a different sum or difference of cubes, okay? So that may apply here. Step 2 is for you to multiply straight across, so multiply straight across. And step 3 is to simplify. Okay, so make sure you write these somewhere in your key points. So here we are multiplying, or it says find the following product. So that means we need to multiply, meaning we need to factor something first before we simplify. Okay, so right here we have, I look at my numerator, x minus 2. Nope, I don't have a GCF. 3x plus 9, I can factor out a 3. And this becomes 3 times x plus 3, and then here I can factor out a 3 as well. It becomes 3 times x plus 2. And then I can factor out a 2, I get x minus 2. And then from here, I'm going to draw a full bar here, and I'm going to show these as such. Okay. And then here, 3 times x plus 3 times 2, times x minus 2. Now I'm just going to apply my commutative property one more time to rearrange my factors. So eventually, to see if I can apply the property of 1. Okay, so I have 3 times x minus 2 times x plus 2. I'm going to line a few things up here. So I have 3 times 2 times x minus 2 times x plus 3. So I notice here I can apply the property of 1 for 3 over 3. I get 1. X minus 2 over x minus 2, I also get 1. And that's going to equal x plus 2. And then 2. Oops, that's a weird 2. Again, another weird 2. With 2 times x plus 3. Okay. All right. So that's all I have for you all. So what I want you all is to summarize your notes. Use any of the vocab words that you saw in the beginning. So go back and check those out, and you're done. Bye.